Today we're going to talk about parallelogram properties, figure out what makes a parallelogram. Which of those characteristics give it the name parallelogram? So we'll talk about that today, and we'll first start off by just exploring in GeoGebra and figuring out what some of the properties of parallelograms have and always have. So you can click the link to this app on the website if you'd like. Otherwise, let's just take a look here and see what characteristics we have in a parallelogram. All the measurements are given for us. Take some time to look through that, and if you have this open up on your own screen, you can drag it around and it maintains, it stays a parallelogram, but just take a look at some of the measurements and see what kind of properties that these parallelograms have. So maybe some of the things that you noticed, maybe you noticed right away that opposite sides appeared congruent, opposite angles were congruent, and these diagonals, they bisected each other, which means they're split in half at the point where they cross. So those are all what makes a parallelogram a parallelogram. We're going to write those down in our notes here. But parallelograms have both pairs opposite sides parallel, both pairs opposite sides congruent. And so, that is the definition of a parallelogram. So we can put that down here, that if a quadrilateral is a parallelogram, its opposite sides are congruent. So in parallelogram PQRS, QP will be congruent to RS, and QR will be congruent to PS. The other thing that we saw on GeoGebra is that the opposite side angles are congruent. So angle P is congruent to angle R, and angle Q is congruent to angle S. So a few other properties that go along with that. Since parallelograms have opposite sides parallel, we've got that property of a transversal cutting through two parallel lines that we talked about earlier in the year. So we also have consecutive interior angles within our parallelograms, and we learned that consecutive interior angles are supplementary. So if these are our parallel lines, I know that here's my transversal. So these two angles would be consecutive interior angles. And so those consecutive interior angles would then be supplementary. And if they're supplementary, we know that they have a sum of 180 degrees. So x plus y would be 180. And that's going to be true with any of the consecutive angles. Since all opposite sides are parallel to each other, I know that these two would be consecutive interior, these two would be consecutive interior, and so would these. And opposite angles are congruent, so we can call these x and y. The other thing that we mentioned was the diagonals bisect each other. And we know that when we talk about bisectors, we know that it splits them in half. So here at point M is the midpoint of line QS. It's also the midpoint of PR. So QM would be congruent to MS. And PM would be congruent to MR. So those are properties of parallelograms that we can apply and use to help us solve problems when we know that we have a parallelogram. So in this first example, we want to find the values of x and y. So I know that opposite sides are congruent, so 12 equals x plus 4. Therefore, I know that I can set up an equation, x plus 4 equals 12, and solve that, so x would be 8, because 8 plus 4 is 12. Opposite sides are 12. Opposite angles would be congruent, so y would equal 65 degrees. Why don't you take the time to look at the examples in the bottom, 3, 4, 5, and 6, and find the indicated measures. Pause the video and restart it when you're ready to check out the solutions. Okay, so in parallelogram JKLM, we know NM is 2, because KN is 2 and diagonals bisect each other. KM would then be 4, since it's the full length. JML would be 70 degrees, because this angle here is 110, and we know angle JML would be supplementary with that, so that leaves only 70 degrees remaining for that whole angle. And then KML, this angle here, would be 40, because 70 minus 30 is 40. So we'll take a look at these 4 theorems and fill those out. The first 2 are converses of those original theorems that we came up with after looking at the properties of parallelograms. But if both pairs of opposite sides of a quadrilateral are congruent, then we can say the quadrilateral is a parallelogram. So if AB is congruent to CD and BC is congruent to AD, then we know ABCD is a parallelogram. And if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if angle A is congruent to angle C and angle B is congruent to angle D, then we know ABCD is a parallelogram. So both opposite angles need to be congruent. If one pair of an opposite side of a quadrilateral are congruent and parallel, then we know that the quadrilateral is a parallelogram. So if we can just find that one side is congruent and parallel, we know that has to be true, because we know that the other sides have to be parallel and congruent as well. So if BC is congruent and parallel, they're a parallelogram. Then finally, if the diagonals of a quadrilateral bisect each other, we saw that quadrilaterals, their diagonals do bisect. So if they do bisect, we know that they are a parallelogram. Okay. So these are properties you want to look for if we want to prove that a figure is a parallelogram. So we're going to work our way through a proof in order to take what we know about those properties of what makes something a parallelogram and see if we can find that and go from there. So first of all, we're given that this quadrilateral is a parallelogram. We want to prove that angle A is congruent to angle C and angle B is congruent to angle D. So if I want to prove those angles congruent, we've already talked about how they are true, but why are they true? So let's make up this proof. So first of all, I'm given that quadrilateral ABCD is a parallelogram. And that's given. I'm just going to abbreviate here, a parallelogram. I'll just spell it all out. Parallelogram. Now, that gives us that it's a parallelogram, but let's add a diagonal in here. Because really, we like talking about triangles in geometry. So if we make a couple triangles, and then we know that if we can prove triangles congruent, then we can prove corresponding parts of congruent triangles congruent. So I'm going to create 2 triangles. I'm going to do that by saying I'm just going to draw BD, because I can say between 2 points there is one line. There's always a line between 2 points. So I can just draw that line in and say, there's my line. So line BD, which gives me that diagonal, and it splits this figure down to 2 triangles. What I know if it's a parallelogram is opposite sides are parallel. So I know that AB is parallel to DC, and I know that AD is parallel to BC. And the reason is because that's just opposite sides are parallel in a parallelogram. It's just a property that a parallelogram has. Okay. So the next thing can take into account those parallel sides. So if I have a parallelogram and that diagonal cutting through it, parallelogram, spell it right. So if that diagonal cuts through it, that's my transversal. So I know alternate interior angles are congruent. So the next thing that I can say is angle ABD is congruent to angle CDB and angle ADB is congruent to angle CBD. And that would be alternate interior angles theorem. Okay, next, well, I've proven two angles congruent in a triangle. I just need to prove a side now. And where can I find a side? Well, they both share a side, BD, that diagonal that we drew in. So I can say that BD is congruent to BD. And that would be it because this triangle share the same side. And that would be the reflexive property. So since now I have two angles and the side between those two angles, I can say the two triangles are congruent by angle side angle. So I can say now that triangle ABD is congruent to triangle CDB. Make sure I get the corresponding angles correct. Now we would say is angle side angle congruence of triangles, and because of that, angle A would be congruent to angle C, because corresponding parts of congruent triangles are congruent. And then I could also say angle, do that same thing and go through and prove triangle ACB congruent to triangle CAD, going through the same process. Alternate interior angles are congruent, share same sides, so the two triangles are congruent, so alternate or opposite angles would be congruent there as well. So why don't you go through this and try to prove if we know that AB is congruent to CD and BC is congruent to AD, how do we know that that is a parallelogram? Pause the video and start it when you're ready to check out this. Check out the proof that I write. Okay, so here's a paragraph proof down below, but if we draw an AC diagonal like I showed you in the proof before, we form two triangles. We know that opposite sides are congruent right now. We also know that AC is shared in both triangles by the reflexive property. So we have side, side, side congruence that shows the two triangles are congruent. So corresponding parts of congruent triangles would be congruent. So BAC would be congruent to DCA. And the same way BCA would be congruent to DAC. So since we have alternate interior angles congruent, the alternate interior angles converse would say that AB would be parallel to, BC would be parallel to AD, and AB would be parallel to DC. So since opposite sides are congruent and parallel, we would say that ABCD is a parallelogram, because that's what makes a parallelogram a parallelogram. So this example here, it says the doorway shown as part of the building in England. Over time, the building has leaned sideways. Explain how we know that SV is equal to TU. Well, we know that opposite sides are parallel and congruent. And we learned already that if opposite sides are parallel and congruent, in our theorem here, theorem 8.9 as listed, that if opposite sides are parallel and congruent, that it's a parallelogram. If it's a parallelogram, we know opposite sides have to be congruent. Next, we have quadrilateral CDEF. For what value of x makes this a parallelogram? Well, if it's a parallelogram, diagonals will bisect each other. So we would know that 5x minus 8 would equal 3x. If that's equal, we solve the equation, subtract 5x from both sides. I get negative 2x. Divide by negative 2, x is 4. If x is 4, 5 times 4 is 20, minus 8 is 12. 3 times 4 is 12. Those are equal. So once again, this just reiterates ways to prove a quadrilateral is a parallelogram. You show both pairs opposite sides are parallel. Show both pairs of opposite sides are congruent. Show both pairs of opposite angles are congruent. One pair of opposite sides congruent and parallel. Or show the diagonals bisect each other. So apply that. Take one of those 5 ways to prove a quadrilateral, a parallelogram, and take this quadrilateral on the coordinate plane and prove that it's a parallelogram. So pause the video and restart it once you're ready to see one of the methods. So you can either prove it by showing opposite sides are parallel, opposite sides are congruent, opposite angles congruent, or opposite sides, one pair of opposite sides congruent and parallel. So go ahead and do that and restart it when you're ready. Okay, so what I did is I used the 4th method listed here in the summary sheet, and I found the slope of opposite sides up 2 over 5. So AB and CD both have the same slope. So since lines have the same slope, lines are parallel. So I know that AB is parallel to CD. And I also found their lengths. I used Pythagorean theorem, made my right triangle for both of those sides, and found that AB equals square root of 29 and CD equals square root of 29. So I know AB is congruent to CD. So since AB is congruent and parallel, I have one pair of opposite sides parallel and congruent. Therefore, ABCD has to be a parallelogram. Maybe you proved these sides parallel or congruent. That would work as well. So we found different ways to prove that a quadrilateral is a parallelogram today. And we've also looked at some of the different properties of parallelograms. Opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and diagonals bisect each other. So do some work in your assignment on that.